Today we're going to do another shapes of graphs problem. And this is going to be one of the ones where we're given certain properties and we then have to figure out what the graph would look like. So we're not given a function, we're given certain properties of a function. So here's what we're going to be given for this problem. We know that the derivative of f at x equals 5 is 0. Okay, and we know, therefore, that that's a critical point, but we'll get to that later. We also know that the derivative of f of x is smaller than 0 when x is smaller than 5. And we know that f double prime of 2 equals 0. So that means that the second derivative at x equals 2 is 0. And we know that the second derivative at x equals 8 is 0. That's going to tell us that we have two inflection points, but we'll get to that later. We also know that f prime, so just the first derivative of x, is greater than 0 when x is greater than, when x is between 5 and 8. So when x is smaller than 5, but greater than 8, that can't be true. It has to be greater than 5. I wrote it down wrong, but that doesn't make sense. So greater than 5 and x smaller than 8. Okay, let's troubleshoot because something's wrong here. If the first derivative of x is greater than 0 between, I wrote down smaller than 5 or greater than 8. Oh, okay, right. So between 5 and 8, it's not greater than 0. That makes perfect sense. So it's going to dip below. The concavity is going to be, the tan line slope is going to be positive, but only between 5 and 8. Okay. X smaller 5 and x greater 8. See, I'm going to leave that in because when you have these problems and it's like, wait, what makes actual sense? You have to go take it apart. Sometimes you have to stare at it for a full 20 minutes. It's part of the process. Okay, do we have any other information? Yes, we know that between 2 and 8, so for 2 smaller, x smaller 8, which is the same as saying that it's that from 2 to 8, the second derivative of f is greater 0, which means it's concave up. And we know, lastly, the limits of x as it approaches negative and positive infinity, which is that limit x to positive infinity, x equals 3, and limit x to negative infinity equals 3. What's that going to tell us? It tells us that we have a horizontal asymptote at 3, right? So now let's go through and let's figure out what these things all mean. Let's start from the start. We know here that the first derivative of f at x equals 5 is 0, and that means that that is a critical point, which may or may not be a local max or min. We also know, let me write that down, max, min, we don't know yet. So we also know that the first derivative of f is smaller 0 when x is smaller 5. What does that tell us? That tells us that the slope of the tan line when we are here from 5 to negative infinity is going to be negative, which means it's going to be something like this, or it's going to be something like this, but it's not going to be like this or like this, right? I'm not sure if you can see my cursor, but okay, so it's going to be like this or like this. So let's write down negative slope of tan line. I'll just write negative slope for x smaller 5. Okay, what else do we know? We know that f double prime of 2 and 8 is 0, which means we have inflection points. inflection points, which is where the concavity changes. So the next thing that we know is that f prime of x is greater than 0 when x is smaller than 5 and greater than 8. Well, that was the one where I had a little bit of confusion, but when you look at it, that means that between 5 and 8, it's going to be a negative slope of the tan line. So I'm going to write 5 smaller, x smaller, 8, negative slope. Okay, so we also know that between 2 and 8, f double prime is greater 0, which means that between 2 and 8, between 2 here, I'm going to take a different color, between 2 and 8, it's concave down. It's going to be like this, right? Okay, so that's good to know. I'm not going to draw it yet because we need to look at our last two properties, and then we're going to try to put it all together so it all makes sense so that every property is fulfilled. The last thing that we know is that to negative infinity and to positive infinity, we have the limit of 3. And that tells us horizontal asymptote. That's how you check a horizontal asymptote, is checking the limit at negative and positive infinity. So asymptotes, horizontal asymptote. And what I said here was supposed to be the concave down for 2 smaller x, smaller 8. Okay, and you might think, like, what do I do exactly? And sometimes you just have to mess around. You have to draw a sketch. It has to be, I'm going to do it, the first time on this one because I have pre-done the problem. But if you're doing it at home and you're doing it alone, and you just have to mess around with it until everything makes sense. Everything is the way that it should be. So the first thing that we're going to do, we're going to start with the critical and inflection points, right? We know, what's a good color? Green is a good color. We know that we have a critical point at 0 and f prime of 5. But f prime of 5 is not going to be, it's not going to be the same on the original function, right? So we don't know exactly what point that would be because we don't have a function given. But we know that at 5, there's a max or a min, right? And we're gonna go ahead and put a point here at 0, 5. Well, I mean, at 0, 5, you could have a max and min somewhere else, but because we don't have a function, we can't plug it in. So I'm just going to put it here for now. What I'm also going to do is take the inflection points and just we know that the inflection points are 2 and 8, and we know that, what's more intelligent? Bear with me here. We're going to work together a little bit. Let's put in our horizontal asymptote, okay? Let's just go ahead and put it in because that's going to have rather an effect. And then so that we know that that isn't the graph, I'm going to just make that a dotted line. Okay. So we have a horizontal asymptote, and I'm going to write that in because otherwise it might be confusing. Asymptotes. Okay. We know that here and here, it's going to be going to this line. It's not going to go above the line, right? So we know that everything we do is going to be between 0 and 3. So let's think about the inflection points, 2 and 8. We know that from 2 to 8, it's concave down, which means that from 2 to negative infinity and 8 to infinity, it's going to be concave up. And we know that these are inflection points, so it only makes sense that these would be points at which it went from concave down to concave up, something like that, right? So we know that. We can kind of put that in. We're going to sketch it. Maybe I'll put in a nicer version at the very end, but this is probably more helpful anyways. So we've got something like this, kind of like if you had x cubed, right? Okay, so these are crossed off the list. This one isn't really crossed off the list yet because we don't really know. I mean, we know that when you set the derivative equal to 0, you get 5. But you don't know that that is on the x-axis. You know, it could be. It could be on the x-axis. Looking at this, it really makes the most sense. It's probably going to be on the x-axis. And the thing with problems like this is that there's other options for ways a graph could be shaped. It could look different ways and still be valid, right? So you have to make certain decisions so that it makes sense with the rest of your criteria. So let's go over to the slopes. We know that between 8 and 5, the slope is negative. Does that make sense? It really actually makes a lot of sense because we know that between 5 and 8, the slope is negative, and that makes perfect sense because actually, that looks like it's positive. Between 5 and 8. Okay, yes, sorry. Between 5 and 8, it's positive. I was reading it wrong. So between 5 and 8, it's positive. So let's just say, since we know it's positive between 5 and 8, we already have this like inflection here, that we know that this is going to be a positive slope right here, from here to there. So we know that, and we've crossed that off the list, we've put it in. We also know that it's going to be a negative slope when it's smaller than 5. So everything smaller 5 is going to be a negative slope. So that makes me think that since we're approaching 3 here, this is always going to be asymptotically going closer to 3, but with a negative slope, right? It's never going to reach it, and it's always going to be like this. It's always going to have a negative slope. So we kind of have that side done. We don't know we don't know where it exactly crosses the y-axis, but it's pretty fair that it's going to be near 3, right? So the only thing that we really have left to do, we've done these, the only thing that we really have left to do, and we know that the concavity is positive between 2 and 8, and we have that correct, right? This is a positive concavity, so that's done. We also know that for x smaller 5, the slope is negative. Have we got that? Yes, we've got that. We have a 0, 5 as our critical point, which makes perfect sense, so that can count. And then we also know that since between 5 and 8 the slope is positive, that between 8 and infinity, it would still be positive because it's only negative for x smaller 5. So it makes perfect sense that approaching 3 here, asymptotically, so it'll never reach it, we are going to also have a positive slope. Okay, so I struggled a little bit with you guys there because it's been a while since I did this one, but I don't think that's bad because, even when you do a lot of math, sometimes you just forget things. So this is what our sketch should look like. So keep in mind that this is just an asymptote. It's not part of the graph, obviously, because then it wouldn't be a function. So we have, let me take a brighter color. Let me just recap. We have from negative infinity to positive infinity approaching 3. When we get to our inflection point, our concavity changes to up because until then it's concave down. So when we get here, our concavity changes to up. And we go down, we start to have a negative slope. At 5, our slope becomes positive and it never gets negative again, but our concavity is still up. But at the next inflection point, our concavity changes. And even though the slope is still positive, the concavity is now concave down. And that is what our graph should look like. So that's going to go on to be positive, and from here it's going to be negative. I don't know why that turned white. That's so weird. Anyways, I hope this was helpful. There's a lot of problems like this. I may well do another one. And have a blessed day.